Hello 8th graders, in this IXL video we're going to be taking a look at assignment R3 on the Pythagorean theorem. R3 has you find some ones that are missing a leg, other triangles that are missing a hypotenuse, so it just combines R1 with R2. Your job is really to be able to find missing sides for any kind of right triangle. And so with that in mind, we're going to take a quick look, a refresher at our notes here, and remind you that there are two versions of this Pythagorean theorem equation. The a squared plus b squared equals c squared version is a lot easier for me when I find c, the hypotenuse, and I like this formula, c squared minus a squared is equal to b squared, to help me find the missing legs. So my big thing throughout R3 is really going to be, as I take a look at these problems, I'm going to be asking myself, am I missing a leg or am I missing a hypotenuse here? And for our first example, we see that we're missing, I'm going to put a little red box around it, we're missing the long side. We're missing c here. So in my case, I'm going to go ahead and use the formula a squared plus b squared equals c squared. Because that formula is always best, for me at least, whenever I want to find c, this is already set up to help us solve for the long side. So now I'm going to go ahead and plug into that formula. I'm going to plug in a 10 for A, because that's one of the short sides or legs. I'm going to plug in a 24 for B, because that's the other short side or leg. And our job, let me fix that color there, is to take this new equation that we have in red now and do those exponents out. 10 squared and 24 squared. I know that 10 times 10, we'll put this here in blue, gives me 100. I think all you know that. And 24 times 24, you could use a calculator if you want, but it makes 576. And then at that point, now that we've squared those exponents, you should be familiar by now, my next step is to go ahead and add together the 100 and the 576. So when I add together the 100 and the 576, go ahead and show a little wedge that we're adding those together, we get 676. And that needs to be equal to c squared. Now, I don't personally know what number multiplied by itself makes 676. I'm guessing 26, because I know 25 times 25 is 625. But I'm not sure. I'm going to go ahead and use a calculator to double check on that. What is the square root of 676? And you can see that on the screen now up in the toolbar. The square root of 676 does make 26. 26 squared would give you 676. So that there tells me that my final answer here is going to be 26 for C. And as I look here, I put that 26 millimeters back onto the right triangle. That looks pretty darn good to me. It should be a little bigger than the 24 millimeters, but not too much, so 26 looks very reasonable to me. So there's our answer. That was finding a missing hypotenuse, a missing long side of the right triangle. Now our next one, as I take a look at it here, I'm asking myself again, am I going to need to find the missing leg, or am I going to need to find a missing hypotenuse? And again, this is another one where I don't know the big side. So in the interest of variety, I'm going to skip to our next question and try to find one where we're missing a leg instead of a hypotenuse. And turns out for this one, they're not being cooperative with us. They give us another problem here where we have two legs. We have the two short sides, and we're missing the hypotenuse. We're going to do this one out together here. I would encourage you to pause the video, try to go as far as you can yourself, because we just did an a squared plus b squared equals c squared one. And now as you're coming back from pausing that video and doing this problem on your own, I will show you how I'd do it. I see I'm missing the big side c, so I'm going to use this formula, a squared plus b squared is equal to the biggest side squared. And I'm going to plug in the 6 and the 2 for the a and the b. So I get 6 squared. Instead of a squared, I get 2 squared instead of b squared, and that still needs to be equal to c squared. Whether we're adding or subtracting, we need to first do the exponents. Here we're adding together those squares, so I'm going to square them out first. 6 squared is 36, and 2 squared is 4. And now that I've done those exponents, here I'm finding the bigger side, so I'm adding together those two squares, and 36 plus 4 is going to give me 40. As you should hopefully be familiar with by now, our last step of Pythagorean theorem, the way we cancel out the exponent of 2, is to take a square root. The square root of c squared will just be c. And I'm going to need to go to a calculator to figure out what number multiplied by itself gave us that 40. So I'm putting the square root of 40 up here right now onto my Google toolbar calculator. Square root of 40, I see 6.324. I'm going to just put the 6.324, and then the dot 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 is my way of saying, and math's way of saying, hey, this answer doesn't stop perfectly at 6.324. It keeps going a little bit. We've got that dot dot dot. The decimals keep running forever. And now I'm going to use my red marker again to highlight this needs to be to the nearest tenth. We see that in the word problem here. So I'm going to put a line right underneath the tenths place, one spot after the decimal point, and I see this 3 there. And afterwards, I see a 2. And because I see a 2 after, I'm not going to have to round up to 6.4. 32 is a lot closer to 30 than 40, so I'm going to leave this at 6.3 because 32 is closer to 30 than it is to 40. So you see here, one way they just make it more difficult is to go ahead and provide you with numbers that, even though they were smaller to begin with, when we took the square root, we got an irrational number, and that's one of the ways IXL makes this tougher on y'all. We're going to do one final problem together here on this video, but I believe you're in really good shape and don't need me at this point. I would encourage you to pause the video, think through, and try to do this whole triangle on your own. And you might be saying, Mr. Doherty, that's not a great formula up there. Maybe we should delete it. I'd agree with you. Now that you've paused the video and tried to do this assignment on your own, I'm going to point out what I was trying to give you a hint towards. This is a triangle where we already know the big side, C. And it's a triangle where one of the shorter sides, what we could call A and B. You see A is up there already. We don't know it yet. And we could then call B the one that's 7 millimeters. So here, I'm not going to be using my a squared plus b squared formula. I'm going to use c squared minus a squared equals b squared, because I already know the big side here, and this formula is easier to use to find a or b. I'm going to swap the letters a bit. The b and the a, they're interchangeable just because here IXL happened to call a the missing side. So I'm going to say c squared minus b squared is equal to a squared. Big note to take out of all this, whenever you know the biggest side, you're subtracting the square of one of the legs to find the other leg's square. So here we'll show red for the first step. We plug in a 10 for C, we get 10 squared. We plug in a 7 for B. Gives us 10 squared minus 7 squared, which needs to be equal to the other leg squared. Switching to blue to do 10 squared is 100, 7 squared is 49, so our formula becomes 100 minus 49 is equal to a squared. In green, we're going to combine or subtract that 49 from 100, and that gives us 51, which needs to be equal to a squared. Now a is going to be a little more than 7. I know 7 times 7 is 49. I need to take the square root here to know exactly how much a is, because they want me to round to the nearest tenth. You see that there. And the square root of 51, which we'll put up here onto the calculator, is going to be 7.1414. So we'll go ahead and write that here in green, 7.1414. We should put it in purple. And that's equal to a. Now that decimal kept going. If I'm being really exact, I should put a dot 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 there, just to kind of be clear, hey, this decimal is irrational, it keeps going. And now I can focus on rounding to the nearest tenth with this answer. The first one is in the tenths place. I look at the digit right after it, which happens to be 4, and since that's less than 5, it tells me I can keep it at 7.1. I'm closer to 7.10 than I am to 7.20, so I'll round off to 7.1 instead of 7.2. That gets us to the end of our video. As you see here, using this formula, picking which of the two related formulas is easiest for missing legs or hypotenuses is really the key to R3. If you do have any questions, as always, you can send me an email or a GChat, whether you're a Mildred student or anywhere else in the country, and that is ddoherty3@bostonpublicschools.org. Thanks again for watching to the end of the video, and thank you for your hard work as you figure out Pythagorean theorem.